What's up, guys? For this video, we're going to be talking about arithmetic sequences. So basically our fancy name for when we have a sequence of numbers where we're adding something over and over again, even if that something might be a positive or negative, a whole number or decimal or fraction, anything like that. We're essentially counting by something over and over again. I'm going to kind of reduce down the formula or like the template of a formula to just a couple blanks to fill in to try to make things a little bit easier to understand. So for this IXL and for the Algebra 1 version as well, we're asked to give an expression and use n as our variable, and n represents whatever step we're on. So like this would be step 1, step 2, step 3, step 4, and so on. So each time we're going to have a similar setup of a blank times n and then plus or minus some other blank. So what goes in those blanks? The first one you're going to have every single time. The second one you may or may not have, dependent on your given sequence. So the first one is just, we'll say, whatever you're counting by. So in this case, to go from 8 to 16 to 24 to 32, we're counting by eights. I would put an 8 in that blank there. So let's fill that in, maybe something like this. If you ever look at these and you're not sure, so maybe they are a decimal and it's not obvious right away, or maybe it's negatives and not super strong with negatives off the top of your head. Anytime, if you're unsure, you can take any number in the sequence, so let's say like 32, and subtract the one right before it. So 32 minus 24, that gives you 8. That's the number you're counting by each time. And then how I would suggest thinking about this is, if this number in the green, the one I already put in my blank, the one that I could go ahead and type in right here, if that number matches the first number in your sequence, so I have an 8 here, I also start with an 8, I don't need this quote-unquote extra at all. The reason why is basically this is saying I'm counting by eights and I'm starting at 8. So I don't need to shift my counting by 8 up or down at all to get to my starting point. This would actually just be a 0. We don't need to worry about it. Let's go forward and try to find one where that would change. I like that they just got rid of the green for me. I was going to do that anyway. It looks like my plus and minus disappeared for some reason. That's okay. So let's add that back real quick. So plus or minus, dependent. So let's think about this one. I have a negative 62, a negative 61, a negative 60. I'm getting closer to 0. One way to think about this might be like a number line. So like 0's up here. Say negative 62 is all the way down here. Going towards negative 61, negative 60, negative 59. I'm heading towards the positives by 1, so I'm counting by a positive 1. Eventually I'd hit 0, then go 1, 2, 3, so on. So what I have right now is that I'm counting by ones, but I don't start at 1 this time. So I need to either add or subtract to where I get my counting number down to the starting place. So that I count by ones, but I'm starting at negative 62. So if we're currently at 1, this is super not to scale, but it's fine. We need to think about how far over, and we'd be subtracting, how far down do we need to go from 1 all the way down to negative 62. So if we're at 0, that would be 62 that we're subtracting. But since I'm at 1, I need to account for that as well, and I'd actually be subtracting. So let's get rid of that. I'd be subtracting 63. So minus 63. So counting by ones, that takes me to my starting point, and then that would represent the pattern going on here. Okay, so let's clear off for a second here. That's about the extent to it. Let's jump ahead and make sure there's nothing else for us. Okay, so counting by 70s, but you start at 70, so you wouldn't have any extra. Okay, something like this. Man, it really keeps throwing the same term at me, doesn't it? It it really wants me to figure out the 70, 140 thing. Okay, let's do it. So, looks like I'm going from 70 to 140 to 210. I would be counting by 70s. So I'd have 70 in. My first number already matches my first term in the sequence, so I don't need a plus or a minus anything. It'd technically be a 0, so we don't even have to show it. But then it also asks me what's specifically the 52nd term. So that's what this formula that you made gives you. It allows you to plug in any term number for n. Whatever you get spit back out to you as like an output, that's going to be with the value that sits in that place. So what that means is if my expression is 70 times n, you do 70 times 52, get 3,640. That would be the term that if you kept going would sit in your 52nd spot. Let's do one more. So for this one, it looks like you're counting by ones and you're going up one each time because you're getting closer to the positives. 1n. Remember that means 1 times n. So if I'm at 1, but I need to start at negative 33, I need to take away 34 to get down there. Let's erase that real quick. Don't know what was going on there. 1 in, I think I have like a dead spot on my screen or something. Let's try somewhere else. 1 in minus 34. Yeah, good enough. I got that random dot over there. So I'd have 1 in minus 34. My 100th term, remember, it's whatever I get when I plug in that number. So 1 times 100 is 100. Minus 34 would give me 66. Awesome. Okay, so we'll wrap up there. We'll have another one coming for geometric sequences. Hopefully these help you out. See you guys.